We are from the Laboratory for Manufacturing and Sustainability in the Mechanical Engineering Department at UC Berkeley. This presentation is an introduction to systems-level thinking applied to manufacturing. What is a system? A system is a set of interacting or interdependent components forming an integrated whole. Any small problems in the system may lead to whole system failure. We can find such incident in the case of Toyota, where small components have been found to have quality issues and the company has had to recall all related models, resulting in lost customer confidence. The tsunami in Japan and flooding in Thailand disrupted the supply chain in consumer electronics and shows how the global supply chains are linked. In the system level, we are working on the issue of how to analyze, integrate, and manage systems. An example of a poorly designed system is illustrated by the far side cartoon. This would not be an effective nor efficient system, as the boat would go around in circles as a result of the imbalance. Let's see a simple view of a manufacturing system. A unit process at small scale can be integrated into a larger scale of complex processes. With logistics support, this system can be extended to supply chains of products. A factory is composed of various machine tools. In this factory example, there are 3 processes. To manufacture the products, the factory needs to define manufacturing structure among different processes and material flows. On the other hand, the factory needs to share product-related information across processes. Due to huge amounts of data, generally data management systems are used in the factory to keep the system in control and processes working together. Inside this factory, supporting utilities like lighting, HVAC, and water are also important. This is the factory system, and if we extend our boundary further, there would be a larger system which includes this factory. Going up one level, we have the whole supply chain as our system boundary. In LMAS, we are also interested in greening supply chains. One of the related projects in LMAS is to find out the supply chain network design to minimize greenhouse gas emission. In this project, we need to decide where to locate a warehouse and how to ship products from the manufacturing facility to the warehouse. This problem can easily be extended to other parts of the supply chain. With this problem, it is important to characterize and understand the relationship between transportation and warehouse activities. The relationship has to be included in the whole system in order to find the optimal supply chain design that minimizes carbon emission. For many products, the manufacturing system can be viewed as a web-like or inverted pyramid structure where smaller processes feed into larger ones. As we can see here, the raw materials or supplies at the top level are used for making individual parts or components. These individual components will then be assembled or compiled to make up the final product. This is, of course, an oversimplification, but demonstrates the basics of how the manufacturing structure as a whole is laid out. In LMAS, we are working on developing sustainable manufacturing technologies through various projects and continually improving the system.